Welcome to the lair of the Batty Boffin.
Hi there Batty fans, it's a little GCSE exam practice. This is higher level we're doing today. Now, in this one today we've got Bathilda the Batty cat who's learning to drive. And as part of her driving lessons she has to learn the stopping distances at certain speeds. And here we have got her speed at 30 miles an hour, 50 miles an hour and 70 miles an hour with the stopping distances. These ones are based on cat leaps, which are kind of approximately meters but not quite. So at 30 miles an hour it takes 30 leaps to stop, at 50 miles an hour it takes 70, and at 70 miles an hour it takes 126. Now, being of a mathematical bent, Bathilda has worked out that this isn't a linear relationship. We can tell that because that goes neatly up by 20s and that goes up by 40s, and then that's not 40, so it's not, it's not a nice linear relationship. It's in fact related by this. Okay, the length is equal to some number times s squared plus some number times, oops, that shouldn't be there, times s. So for part A, you need to determine, please, the values of A and B. So pause the video, have a go at that now. Right, let's look at that. We're going to solve this one with some simultaneous equations. We've got A and B, two variables to discover, so we're going to need two equations. I'm going to use this set of data to create one and this set of data to create another. I'm not going to use that one because the numbers are too big. So for the first one, with a length of 30, we have 30 equals A, we don't know what that is, times by s squared. S is 30, so s squared is 900. 900 times A, plus B, which we don't know, times s, which is 30. Okay, and then we're going to do the same thing with this set of data on here. So the length 70 equals A times the speed squared, 2,500, that's a 5, plus B times 50. I'm going to call that equation 1 and I'm going to call that equation 2. I'm just going to tidy these up a little so that they look more like the normal way we have them. Now we're going to balance them up. I think I'm going to balance out the b's here. So I'm going to do 5 times this equation and 3 times that equation. So 3 times equation number 2. Okay, 3 times 70 is 210. And then I'm going to do 5 times equation 1. So 5 times that is 150. Okay, hopefully this method is clear to you. If it's not, is this looking completely, what's she doing here? Check out some of the other Batty Boffin videos where I'll go through this rather more slowly. Here I'm going to subtract them to make this all disappear, so that gives me a 60 on the left hand side equals 3,000 A's plus no B's. I'm going to pop up here now. Right, so that gives us A equals 60 over 3,000 and 60 over 3,000 down to 1 over 50. Okay, I'm going to leave that as a fraction. You could put 0.02 if you wanted. Okay, so that's for A. Substituting into that one there, I'm going to say 30 on the left hand side. My pens keep running out. It's because it's really hot here. 30 is equal to 900A, so I'm going to put that as 900 over 50 plus 30B. Okay, 900 over 50, that's 90 divided by 5, which is 18, isn't it? So subtracting 18 from each side, we're going to get 12 equals 30B, so which gives us a B equals 12 over 30, which is cancelling by 3's in that, gives us a 4 over 10 or a 2 over 5, or you can put a 0.4 if you want. Okay, and that gives you your final equation should look like this. That I'll do it here in green. We've got L equals A, which is 1/50th, so that's S squared over 50 plus, and then B is 2/5, 2S over 5. there's our final equation. You can put those as decimals if you want. Okay, I'm going to wipe down the board. We're going to come back and we'll look at part B. Right, here we are for part B. So that's the formula we've got, and we're going to be using that. Over there on the chart, you'll notice that there's another value with a question mark above it. Now, the value for the stopping length, the stopping distance, is 50, which is exactly halfway between these two values. So for part B, I'd like you to estimate, we're not working out at this point, I'd like you to estimate what the value in there should be. That one is halfway in between the values either side. Is that one going to be exactly halfway in between the values either side, or is it going to be less than halfway, or is it going to be more than halfway? And justify your answer. That's part B. Part C is find the value. Okay, off you go with those. Right, let's have a look at those. Now the first one's an interesting one. We've got a halfway value for L. Is it going to be halfway in between up there? Well, hopefully you'd look at that and say, no, it isn't, because it's not linear. We can see from the formula quite clearly it's not a linear relationship. This is in fact a quadratic. The fact that you've got these over 50s and over 5, it just means that the coefficient of s squared is 1/50th instead of like 3s squared or something like that. It's still a quadratic, which means that the graph of it is going to look something like one of those. It's that kind of shape. Particularly, it's this curved shape. Now let's just examine what happens. If I pick a point here and another point here, okay, with their little values, okay, so this would be like the S for speed, and there's your L at the top, your X and Y, so that would be your X and that would be your Y. If we go halfway in between the values for L and read it along, we see that it does not come halfway in between the values on the S axis. It's actually closer to the higher one. And on any curve that's this kind of scoop shape, you're always going to get that. So the answer is that the missing value up there will not be exactly halfway because it's not linear. It should be closer to the higher value. Probably not by much, because these are pretty small coefficients, but it still should be closer to the higher value. So that's part B. Now, for part C, we actually need to work out the value. So there we're going to be solving a quadratic. Right, we've got a value of L is 50, and we've got S, which we're going to find. It's exactly like finding the value of S, only it's X in this particular case. So we're just going to start off by substituting in the value of L, and then we're going to turn it into a standard quadratic format. Here we go. There, hopefully that was fairly straightforward. We're substituting in, because we've got fractions down there, multiplied by whatever's on the bottom of the fraction, which is that really ugly looking 50 down there, multiply through, don't fit equals to, multiply that part, that one as well, and we get s squared plus 20s minus 2500 equals 0 for our quadratic. Right, at this point we're going to solve a quadratic. We could use factorising. It doesn't factorise. We could use completing the square. I'm actually going to use the formula this time. So I'll just rub out some bits here. The quadratic formula, hopefully you know, minus b plus or minus the square root of b squared minus 4ac, whole thing over 2a. We have a value of 1 for a, 20 for b, and negative 2500 for C. So again, I'm going to do this bit all kind of speeded up, A, because it looks quite funny, and B, because I mean I'm sure you can write out and substitute in the formula. So here we go with substituting into the quadratic formula. Right, we end up with negative 20 plus or minus the square root of 10,400, which is not a square number. So when you square root it, you're not going to get a whole number, which is why, of course, it didn't factorise, whole thing over 2. Right, at this point we grab our trusty calculators and we go negative 20 plus the square, where's my square root? The square root of 10400 equals that, divided by 2 equals that, make it put in actually decimal, and we get S equals 40.99, or to the nearest whole number, the speed is 41 miles per hour. Well, we said it should be slightly over halfway, and halfway would be 40, so it is slightly over halfway. Okay, that's the end of that one there. Hope your brain's not oozing out through your ears with too much work. If it isn't, pop back and we'll join you for another bit of exam practice later on. Bye for now, Batty fans.